My name's Chris Cummings. I've been a field day delegate a few times. Kind of fun to be on slightly on the other side of the bench here. I'm a network automation software engineer at ESnet, the Energy Sciences Network. I'll talk a little bit about what that is and why that's relevant to service provider networking. But the talk I want to give is a little bit of slideware first, but don't worry, since it's field day, we'll be doing a demo, assuming everything works just fine. But the talk title is a real-world approach to intent-based networking and service orchestration, and that's a lot of words. So I'll kind of dive into what my definition of intent-based networking and the definition of what the team that I work on, has been using as a guiding principle for the stuff. But we'll kind of go over some slides and then we'll go into a demo where I'll actually show you the tools we use and actually do some provisioning of services in a sandbox environment that we've created. So real quick, what's ESnet? Well, ESnet is a service provider style network, but we aren't really your normal service provider. But as you can see here, we have a footprint that spans continental US, goes over into Europe, and international transatlantic links, things of that sort. We connect with a bunch of international networks, but we're a little bit different. If you look at the internet as a whole, which is what this picture is, you can see this blue circle over a bunch of these clouds. And these clouds are research and education networks. So ESnet kind of falls into the research and education network category. So we're a subset of the internet that has a bit of a different goal. And that goal, at least for ESnet specifically, is to be part of the Department of Energy and more specifically Lawrence Berkeley National Lab out of Berkeley, California. And we basically connect the Department of Energy laboratories to the commercial internet like AT&T, ISPs, Google, all of those companies, right? But we also connect to other national research and education networks, international ones as well, people like Internet2, Géant, some European NRENs, regional networks, things like that. So why do I say we're not quite a normal service provider? Well, a normal ISP is, best effort packet delivery kind of, you know for sure that you can send your packets and, you hope you'll get some of them out the other side. And you have a lot of providers for that exact reason, because you don't want one provider only, right? For us, we're a little bit different. So while a normal ISP might be like a highway where you have a lot of small cars going on and off, maybe local ramps, maybe long haul, things like that. It's very multi-use and very able to work for a lot of things. We're more like, a high-speed train. So we are a big, wide pipe network, right? 400 gig backbone. And what we deliver are elephant flows mainly for scientific workloads. So things like the Large Hadron Collider at CERN in Europe, all the particle accelerators that are part of the DOE lab complex and things like that. So it's a little bit different, but we use a lot of the same technologies. And so I'll talk a little bit here now about our intent-based networking. So what is intent-based networking? It's a buzzword, right? It can kind of mean whatever you want it to be to a degree, but we've taken our own definitions of it that I think fairly align with what the world would generally agree is intent-based networking. So what I think of intent-based networking is it's a high-level definition of a network service itself, right? So you're defining what the service is, but you're not going to say how to implement it, right? So you're going to go into your source of truth system and say, I need this service for a customer, but I'm not going to go into my source of truth system and say, give me a BGP peer with this IP address and this med and this local preference and, GT, blah, 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 all these settings, right? That's not what it's about. It's more templatized and things like that. So we abstract a service offering from the actual implementation details. And that gains you some benefits around being able to think, in components versus having to understand the whole system end to end, which service provider networks are really complicated. So what's orchestration? Well, orchestration, obviously you're just coordinating a bunch of computer network systems together, okay? The way we use it is we use an orchestration tool to translate our network intent, which we store in our source of intended truth, and we turn that into network configuration, which actually goes on to devices. So much like the conductor of an orchestra, an orchestra does not play an instrument, right? It's just pointing to other things that have their jobs and telling them to do them and checking in on that state. So for us, Orchestrator, it's a workflow-based method for provisioning services. So, you go through the step A, step B, step C, and it, is doing all of these things in order. But one of the main benefits of that is that we're able to, ensure consistency, because with the traditional provisioning method of logging into a router, figuring a BGP session, And getting all that done by hand by an engineer, first off, it's really time consuming. But second off, it might be inconsistent. Maybe I'm going to do it one way, maybe another engineer is going to do it another way. And ultimately, that can result in unreliability for the customer, right? And when it comes to troubleshooting, you go, wait, this layer 2 VPN, how's it set up? Oh, wait, it's completely different than the way all of our other ones are done. Oh, yeah, that's because John did that one. You know how he is, right? So we're trying to move away from that and move towards like consistent, very reliable, repeatable services. So again, the benefits are consistent configs, especially as service provider networks, they get more and more and more complex. And by doing that, you're reducing the chance for human error as much, or at least you're moving the problem space around to software versus configuration by hand. So you kind of move that human error aspect into the service templating and definition stage versus the implementation stage. So you're kind of shuffling that around a bit and hopefully reducing the overall human error. And the goal there is to actually make the network more reliable. Like I mentioned, easier to troubleshoot when things go wrong, and things do go wrong. That's just thermodynamics and entropy, right? When a backhoe comes through and digs up your fiber, things like that, you don't have to worry that the backup link that was supposed to be there, whoa, we forgot to configure LDP on that one because I didn't think of it, right? But also from an engineer standpoint, the idea is that you don't have to spend your job doing configuration and deployments as much. If you template that out and create these, intent-based services, right? You're able to kind of hand that off to a more operational focused group, and your engineering departments are able to spend more time developing services and creating things to offer to your customers and users of your network versus spending a lot of time late night cutovers moving things around, right? You still have to do those things, but you're making it so that the configuration prep is not as huge of a part of it. So less busy work. So what's our actual stack look like, right? I've talked a lot about abstract concepts. Let's actually look at some of the components that exist in our ESnet 6, which is the latest generation of our network that uses a lot of this stuff. So at the middle, we have an orchestrator. Now for us, that is a product, an open source product that you can download called the SurfNet Orchestrator. It's really cool. It's developed by another INRIN. And yeah, it's open source. You just have to configure it and use it and write your own workflows. But as you can see in the middle here, this is like the brain of all the octopus tentacles of our provisioning stack. So we have ESDB, which is another in-house tool that is our source of intended truth, right? So that's where we store our network intent. Think of it a lot like Netbox or Notabot, one of those tools. But for us, it's a little bit more customized, and we've had it around forever since before those were a thing. We have Prefix Manager, which helps us generate, BCP38 filters and crunch through IR data and things of that sort. We have Stardust, which is flow analysis that we've built in house as well. Hard like network discovery services, like what's the actual state of these optics? Are they actually in the right port on this box that we think they are? And topology services, all of these parts and components, right? ServiceNow to actually do incident management and hand over, a customer request to engineers who are doing deployment, right? All at the center of all of these components that make up just our day-to-day lives, we have the orchestrator. And this is where a user is interacting with things. And what the orchestrator does is it pulls from all those systems, combines things, throws it in the Vitamix blender that is its service logic, and then spits out at the bottom actual provisioning data to our network mediation layer. So right here at the bottom, this is what we call our network mediation layer. And you can use anything that can talk to network devices, but the whole point here is you're abstracting vendor-specific implementations of network concepts into just network concepts so that the orchestrator doesn't have to know, oh, well, if this is a Cisco router, I do this. If it's a Juniper router, I do that. If it's a Nokia router, I do this. We use NSO primarily to just say, I need a layer 2, service. The orchestrator provisions that. It doesn't have to think through the vendor details about on Juniper, I twiddle these knobs. On Nokia, I twiddle those knobs. So that allows us a lot of flexibility because we can switch out vendors a lot easier at the very bottom and not have to, redo all of our service logic. So it's just lots of components stacked on top of each other. So this is like an actual engineer's workflow, right? So we kind of have two start points here. So maybe a user requests, I need a new BGP peering. So that'll get entered as a ticket into like ServiceNow. But at the same time, you also have network planners who are sitting out and thinking, how do we want to do BGP peering with customers? What kind of features do we want to enable on these peerings and things like that? So they're designing those things and, building and templating those services into ESDB, which is our source of intended truth. So then a network engineer gets assigned that task. They plan the specifics around it, like, okay, well, what's your IP address? Obviously, like, are we using your IP space or ours? Who's doing the cross connects, all that stuff. They fill that data into ESDB, basically making an instance of that service template that the network planners and designers have already planned out. Then they can go over to the orchestrator and actually instantiate that service, which the orchestrator then talks out to ESDB. Again, we'll see all this in the demo, updates the state of things, talks to our mediation layer, and then ultimately it gets rendered into device config, which, well, then goes on to routers, and routers move packets around.
I have a question in regards to the network planner and the network engineer. Yeah, so when you mean like design network and bulk data imports, like what is it? Like, is it like a template that is being passed from the network planner to the ESDB?
Yeah, so for us, it's basically work. This is the workflow cycle that goes basically between engineers who are designing an actual service offering and then getting that translated into intent templates and actual workflows that the engineers will use. So those things can kind of happen in parallel to each other. And then the idea here is that a network engineer goes and uses just an instance of that versus having an engineer have to go and rethink, how do I want to do this BGP peering that the customer requested from me? I just choose a thing off a shelf that already exists as a template.
Can I follow up on that too? Because I'm thinking BGP peering is actually pretty low level of what I was thinking of as a service. So can you go through a quick, like 3 or 4 examples of what qualifies in your world as a service? I mean, I would have thought, a straight up BGP peer is more of a piece of a service than a service itself, but, walk me through this.
Yeah, so BGP peer is definitely a component of what we call our internet transit service, right? So it's just one thing that's part of that. One thing I'll demo today is our backbone link service, which is an internal service to provide connectivity between two like metro areas, right? So that's like, a backbone link running ISIS, running LDP, running, we got IBGP connectivity going on and all that, RSVP, all the fun protocols, right? Some other stuff like layer 2 VPNs, the ability to actually create a new instance of a layer 2 VPN for a customer and then choose the routers that it gets deployed upon and all of that fun stuff. Those are the probably the easiest ones that come to mind.
You guys have a pretty set service offering because you're, like you said, a little different. You do energy sciences, you have set services. Those are kind of depicted by the type of services, type of networks that you work on. How would you determine what to put into an automated framework when there's, businesses that are coming up with money and somebody shows up with their pocketbook and they want this one-off thing and it's going to be really, they're going to give you all the money?
Yeah, that's been a huge thing, even for us, to kind of balance, right? Because one of our core things that we kind of exist to do is to be able to provide more white glove service, right, to our customers versus them going out. Like it's been deemed by the Department of Energy and by Berkeley Labs that, hey, it's actually beneficial to run our own nationwide network versus just buying services from another one, because what we do is different, more configurable and customizable. But it's always a balance because you have to decide, how customizable do you want things to be? And that's really been the hardest part, I would say, of this whole thing, is actually sitting down and figuring out what it is you want to offer and how configurable you want it to be. And a lot of times what we'll do is do kind of proof of concept or pilot deployments of a service with a select customer before we actually orchestrate and automate it, because we don't know if it's going to be something that we gain value from templatizing and rolling out as much. I hope that kind of answers things a bit, but yeah, it's not easy. That's for sure.
You just hit something there that I was wondering about. If you're doing these one-offs, how do they get, shoehorned into this system? Is there a placeholder, or is it just, back in the Wild West again.
So a lot of these one-off things can kind of be the bane of your existence to a degree, but with NSO specifically, it's not horrible because NSO as our mediation layer is capable of resolving when we design our services properly, it's capable of resolving like what the service itself owns from configuration versus stuff that was already there. So we try to merge a lot of our stuff into the existing config on the devices. Ultimately, I would love to see a situation where you can define the services just as easily in our source of intended truth and build workflows faster than it is to actually configure the stuff on box. That's not where we are today, but the real win is on the things we do 100 times a day, right? And so we're kind of following that 80-20 principle, right? There's always going to be things that it just doesn't make sense to automate. Like it's just way easier to just do it by hand on CLI. So yeah, hopefully that answers things.
So I was going to also make the point that because we're using automation to get rid of like the bulk of work that is, you know, cookie cutter stamping over and over again, those edge cases become actually easier to stomach and easier to develop on because you've got most of the work out of the way. Now you can iterate, improve, expand, change the scope of the service that you're offering.
Exactly. And there's some things that are just components that don't change, like a layer 3 interface, right? Like that is reusable across other services. So when we build a lot of these components in our orchestration tooling, the idea is to get as many building blocks done as we can. That way we can use them in other services. And it's that classic like dry code, right? Do not repeat yourself. Trying to do that as much as we can with our service design.
So the ESDB part at the top, does that also account for these one-off and customizable things, or do you have to go, you know, when you find you're troubleshooting and you're wondering, you know, why something exists, you know, is it gonna exist in ESDB, or is there a separate place you have to go to find the, you know, the code that was related to the one-offs?
Yeah, so historically, ESDB existed before we had any orchestration. So it was always just a source of, it was still a source of intended truth, but it was where you would document anything. And so even if we did one-off stuff, it was still in there. It's just that you couldn't deploy that in an orchestrated manner because there was no orchestrator and no workflow engine to actually, you know, convert that into configuration at the mediation layer. So that's something we've been doing for a long time. And the goal has always been to keep that stuff documented in a source of truth, even if it's not provisioned in an orchestrated manner. Now, that being said, yeah, like it's really important for us too, just from an operational standpoint, right? Because we have network operators like a NOC that has to be able to support these things. So when we do one-off services, we are pretty stringent about making sure it's at least documented really well. Otherwise, yeah, 3 a.m. when it inevitably breaks, you're in for a bad time. So to do this demo, we're going to use an environment that a bunch of us built. You probably know Nick Baralio. He also works with me and has been a delegate for quite a long time. That's his dog. But anyway, it's this environment called Rover. Stands for Realistic Orchestration Validation Environment for Networks with the R capitalized. Yeah. Like all good software, start with the acronym first and work your way back to what it's going to do. So basically, this is a sandbox where you can deploy a representation of ESnet. It's obviously ESnet's a little bit bigger than just this topology, but it's a representation of ESnet, right? So it's, you know, customers that are using services that we provide, but it's not real customer data, right? It's a theoretical customer that would be using the service. And so we try to represent, you know, basically every way that a service offering we have can be instantiated. And so we use the really cool tool Container Lab to actually spin up Nokia vSIMs and SR Linux and Juniper VQFX and Linux containers and a bunch of stuff to actually spin this up. But essentially with this tool, you deploy to a node, it spins up this network topology, which has a core router and then pre-configured customer devices. You can even see internet exchanges modeled here, things like that. But it also spins up the service containers of all of our actual services that were in the previous slides, right? So we have an ESDB, we have an orchestrator, we have an INSO, we have a pre-service manager, all those tools that we use. So the idea here is that you can give an engineer, you know, type a command, 3 or 4 minutes later, it spins it up on this VM, and you now have a sandbox that you can play with, let's say a new ESDB feature, a new orchestrator workflow, things of that sort, and not have to just, you know, do it live on the real network. So we've tried to separate our testing environment from our production network as much as we can. So this is the topology I'm going to be using for the demo. And let me talk about what I'm actually going to demo. So first thing I'm going to demo is the backbone link. So just between two core routers, we'll actually, if I go back to the diagram, be configuring this link right here. So right now it's plumbed between the two routers. It's connected, but there's nothing up on it, right? So we'll actually step through bringing that up to where it can pass traffic. Then we will do, these four are kind of grouped together. So these are part of our IP transit service. So the first building block is the physical connectivity. So that's actually like layer 2, layer 1, configure an interface, no shut it, add LLDP, those sorts of things, right? Just get the actual service attachment point where the customer is gonna connect into our network provisioned. Then we build our service edge on top of it, which is an ESnet specific term, more or less for like the layer 3 configuration for how we're going to connect to that customer, right? Our prefix lists, get those deployed to the router so that we can do, be good mannered citizens and BCP38 people and filter routes before the customer gives us a full table on accident. And then we have this IP transit layer 3 service that actually takes those building blocks and components and ties them together. And so we'll kind of see that that's one of the strengths of orchestration is that you can build these small components and then tie them together into a larger thing. And I'm not 100% sure if we'll have time to get here or not, but we'll definitely do the backbone link. So first things first, let me get logged into the routers. So over on the left, you will see location 1 CR6 from that diagram. Over on the right, you'll see location 2 CR6. And if I go over to this, so this is the SurfNet orchestrator, right? So over here, I've actually gone ahead and I've pre-enrolled these routers so that the orchestrator actually knows they exist. That's a whole nother workflow that is a lot less interesting perhaps, so not going to show it off here. But it's a prerequisite for being able to do a backbone link between them. And over here, I have ESDB. So this is a list of circuits in this rover environment, right? So we're going to just focus on Z001, which I've already got open here. So this circuit is just basically the intent portion of things, right? So an engineer goes into ESDB, says, hey, I need to document a circuit between location 1, location 2. And it's got all sorts of stuff like, okay, it's a relational database, right? So this lives on location 1 CR6, port 11C21, the other end, location 2 CR6, 11C11, stuff like that. And they've gone in here and they've added that it's a backbone circuit. And at this point, once they've reflected, this is how things are supposed to be, they can go over to the orchestrator and actually deploy that. Now, before we actually deploy things, just to show you that I'm not lying to you, let me actually do, look at LLDP on this box. Helps if you do the right command. No matching entries, right? We don't have any LLDP neighbors at all today. Let's change that. So over here in the SurfNet orchestrator, I just go and I fire off a new process. And the terminology is a little bit different, but we'll call it an ECP group here. Basically, an ECP group is a collection of multiple backbone links. So we'll just select that circuit from ESDB. So the orchestrator has gone out already. As soon as I loaded this page, talk to that source of intended truth and pull the list of all the circuits that are ready to be used in this manner. Now note, this circuit list is a lot bigger, right? So the orchestrator's already filtered things down for us to what's actually valid to be deployed. So we do that. And, at this point we can update, maybe it's a subsea cable, right? And go ahead and hit submit and we'll let that run. So in the background, the orchestrator is basically building a model of what do I need to do to provision this, right? There's no IP addresses listed in ESDB for this backbone link, but we're still going to need those. So it goes out and talks to our IP address manager, says, hey, what's your next available block in the subnet for backbone links that I can use? And it basically reserves those resources in other systems, configures DNS, gets everything set up so that we have the forward records and reverse records and all that stuff, which having done these by hand before we had this, the amount of things that I forgot to do, it's like, oh yeah, I didn't put reverse records. And so then somebody was doing a trace route and they got a little, like having an orchestrator just do that in order for you is really nice. So it's going through, you can actually see the steps that it's stepping through here. We can see it grabbed this block for V4 and of course V6, because why would we not have V6? And it's done thinking through things. So now we actually have a dry run of what it's going to do. So as the network engineer, I can go and look, okay, on device 1, you're setting the description here. All right. we got LLDP enabled with all the right stuff. It just gives you that last moment to be like, okay, is everything good? Is there an RM, RF, R like slash like going on here? Okay, good. So then they can just confirm those results. And I have a packet capture going here. Now, we'll see if this works. It doesn't always work, but I'm capturing between these two routers. So as the orchestrator sends its payload over to our network mediation layer, we will see protocols start to come up and traffic start to flow. So I'm going to hit submit. And let's go over to our good friend Wireshark. Oh, look at that. So there we go. ISIS hellos, all the fun, gooey, goody, good stuff that people like. If I go over to LDP, look at that. We now have a neighbor. If I do show router ISIS adjacencies, what do you know? We've got an adjacency, right? And same thing over here on the other router. It's good to go. So that's just like a brief demo of the backbone link. If I go back to the orchestrator, we can see that it's done. There's a subscription in the orchestrator's database that this exists, and we can now build things on top of it. The really cool thing is if you build services on top of it, you can't just go and terminate this backbone link, right? Because those services above it depend upon this backbone link. So it knows the state of all those things. So now let's go towards what I described as our BGP IP transit demo. So similar setup to last time. Here we have location 1 CR6, and here we have customer edge or customer 1 edge node 1. So if I go back to the diagram, we have location 1 CR6, customer edge 1. And in this rover environment, we have the customers are already pre-configured, right? The whole idea here is we can use it with CI/CD tests. We can test a new workflow. Workflow goes out, provisions things the way that the source of truth has been, configured, and we can actually write tests around: did BGP come up? Were these exact routes exchanged? Were these exact routes rejected? Things like that. So there's a lot of benefit to pre-configuring those customer devices there. That way you have like a reference implementation of how a customer would be configured. And again, that's using Nokia's SR Linux free container, which is fun. If any vendors are out there listening, make your images free so I can use it in things like this. All right, so let's go on over to the orchestrator. Well, before we do that, let's actually look at how this is modeled in our source of intended truth. And again, I've already pre-populated this stuff, so you don't have to watch me do data entry because that's kind of boring. Here we have the overview for the peer page. So we have a peer with AS3152. Its name is customer 1. We're peering with them because of reasons. And we have a bunch of different services that are tied into this autonomous system, right? We have BGP profiles, so they're one of our sites. That means they get this. We accept their mids. We send them default routes, things like that. There's some configurable things that an engineer can do based off their conversations with the customer. And then we actually have a list of the BGP neighbors that we have with them. So because this is a nice linked database of things, we can actually go to that service edge, which I've already got open here. So here we actually have the service edge with the IPs lined out. And what the port descriptions are going to look like, and it's backlinked to those BGP neighbors. And then if we go down, right, so we've looked at the BGP peers, then we looked at the layer 3 interface. Now we're looking at the layer 2 physical connection, right? So this physical connection now shows, okay, on location 1 CR6, port 11C21, and then again, it's showing us the higher level references. And of course, we can see information about the organization themselves too. But now all of that nice fun stuff is done. So we go over to the orchestrator and we start off by doing a physical connectivity service. But before we do that, let's look at the routers. So if I go over here on the router, now look at 11C21, there's nothing configured on it, right? It just says 100 gig. Boring, plain, ready to go, nothing there. Let's fix that. So we go over to the orchestrator, we fire off a process. We do a physical connection. This list is getting longer and longer every day, so I got to scroll. So again, we've pulled from ESDB a list of all the physical connections that are eligible. We got 100 gigs, we got 400 gigs, all of these things. But we're just going to do connection A for customer 1, which is the one we were looking at right here, right? So again, you can see all the detail.
Yes. So how does the ESDB select which interface is eligible physical connection?
Yeah, that's a great question. So basically, the orchestrator has logic, holds all of the actual business logic around like what is valid for what. So in the code of the workflows of this actual new process that we're firing off here, it has rules about what kinds of like what prerequisites have to exist on this physical connection for it to be deployed. So that's all like kind of hidden away in the code, basically. So we go ahead and select that, hit submit. We'll let that run. All right, so obviously we're still waiting on the dry run, so this is still unconfigured. We let it think a bit. Another thing I'd like to show, I guess, just from back on that previous backbone link example, is that now that that's been provisioned with the orchestrator, we have this orchestrator ID link here. So we actually go back and update our source of intended truth with, you know, a back reference to the process that fired it off, so that when you, as a network operator, in the middle of the night, this thing goes down, maybe you need to go, you know, let's say this fiber got nudged in the facility and it's like flapping, and that's causing instability on the backbone. Well, an operator is going to trace down from the monitoring systems. The monitoring system is going to say, it's this link, right? Go here. And an operator can go to the orchestrator, change the metrics, and, you know, cost that link out of our IGP and things like that to, you know, restore stability in case of, you know, flapping or whatever. This is still going. This one's usually pretty quick. Oh, there it is. All right. Patience is a virtue. So again, I'm an engineer. I look at this, I go, wow, that looks like exactly what I would type. Hit confirm, hit submit. Let's go back over the device. It's doing a post to NSO, and it should be done by now. Look at that. They put a description on things, and we've, you know, started off the very basic building block of configuring a customer. All right. That's a pretty simple one. There we go. I guess my auto refresh is not running. So we go ahead and we're going to do a service edge now. So we've got layer 2. Let's build layer 3 on top of that. So now we do the service edge service. Next. Again, this is pulled from ESDB, the valid service edges, right? So this is the actual service edge, I believe, that we're doing. Actually, I'm wrong about that. It is this one that we're doing. So here's the IP addresses 192.168.101, and of course v6. So we go in there, and let's select it. So this is customer 1 primary. So it's on this physical connection. Let's make sure I got the right one. Oh. Do customer 1 primary. All right. Let's go ahead and submit it. Oops. We want it to be up. You can give some operational details, like, do you want this to be deployed in the upstate or downstate, right? So that finished right away. Again, nothing crazy fancy here, but it's just an interface on the router that has IP addresses and all that fun stuff. There's v6, there's v4. So we go ahead and confirm it. Submit. Real quick, if I go over to the router. Oh, I missed it. But yeah, this wasn't here before. You can see it's in the tentative state because I caught it right as it was being configured. If I do this again, you'll see now it shows preferred, right? So now the actual interface has been configured on the router so that now you can talk to the customer. So at this point, we can actually do a ping between the two devices because we have layer 2, layer 3 up and running. So let me do let's see, show network default interfaces. So let me just grab the right IP here. So the customer is 102. Look at that. We can ping across. So now we've done 2 of the 3 prerequisites for internet transit. Let's do the third one. Let's do the prefix list deployment. So this one basically takes IRR data, and we also run our own internal list of prefixes that a customer is allowed to send us that we update by communicating with them. So we'll go ahead and select that customer, tell the orchestrator, for the base route table, we have, of course, other layer 3 VPNs that are tied to this customer that might show up here. Let's just look at the base routing instance for now. And we can even let it select which nodes to deploy for us and let it run. So at this point, what the orchestrator is doing is it's going and talking to another system. So because we're doing a lot of filtering, right? When you are dealing with really large peers, those lists can get really long. Like sometimes like 50,000 prefixes, right? So we didn't want to like keep all of that logic within the orchestrator itself. So we were able to kind of break that off into like a subroutine in a way, right? Where we run that on an external system. So it went out, talked to that external system, said, hey, crunch these prefixes for me. External system did that. And you can see here, it's actually already done that and applied it to the router. So at this point, we've actually even said, it's not worth having an engineer review this, just go ahead and do it as soon as they say they want it done. So it's on the device now. And if I go over to the router, and yeah, sorry, I kind of forgot to show you the before, but you can trust me, right? You can now see that we actually have a v6 prefix list for this customer. All right. We're ready to tie it all together. We've got layer 2, we've got layer 3, we've got logical policy around which routes we want to accept from this customer. Let's tie it all together and actually bring up BGP. Now, again, I have a packet capture here. So you can see traffic going, right? Because we have a actual layer 3 interface up and running between them. You can see my ping that I did earlier, right? And if we filter that then down by BGP, you can see that the customer router is actually trying to connect to the ESnet side router, but it can't yet because it's not configured. But this just shows that the customer is pre-configured. So let me go to the router real quick. And on the service provider side, I'll just show you, our BGP peers. Right now, we don't have any customer-facing peerings. We have iBGP with the location 2 router, right, going over that backbone link that we provisioned early on in the demo, but we don't have anything to the customer. And again, if I look at the customer, they do have peers for us. And yeah, sorry, this shows up kind of goofy, but you can see that over v4, v6, they're trying to connect to us. It's in the connect. It's in the active state. We're not happy. We're waiting for it to come up. Let's fix it. Is that my new tagline? So we go ahead and do layer 3 service. So now we're building upon these subscriptions we've already enrolled and provisioned. So the only possible service edge to actually use that's been provisioned in the orchestrator is the one we just did, right? And note that we don't have to select the physical connectivity, the physical connection that we're going to be using, because that's already been done. Those are already cross-linked to each other, right? So you don't have to reassemble those at the higher levels. It's been abstracted from you. We'll select that prefix list. And let's just skip the dry run. I know it's going to do what I want it to do. Famous last words, right? So go back over to our correct packet capture. There we go. We see the customer sending opens. Sending opens. Come on, you can do it. I go over here, see if I can. We still don't have the peering up. Oh, here we go. Magic's happening. We see opens coming from both sides, keep alives, updates, routes are rocking and rolling across there, right? Let me show you that on the CLI just to prove it. Here we go. We've got 2 new BGP peerings. Again, you can actually see routes are being received. Only 6 of them are active. Like sometimes we might want to test that a customer is sending us bad routes, right? So we know that those prefix filters worked. Again, go to the customer side and you can see, the same thing. They're sending 14, just like that. So yeah, that's it. That's what we've built. That's what we're, using today to configure certain parts of our network. We're always adding more stuff.
Question about operations once you configure the new service. So, you said, right, it breaks in the middle of the night. I go and I change a link. Now, do I have to go back into the orchestrator to change those link characteristics or update that? Or and push the config? Do I do it directly on the CLI? How does that kind of interaction go from in break fix to make sure you don't end up out of sync?
Yeah, no, it's a great point. So there is basically safety measures. If somebody does go into the CLI and change things, the orchestrator and NSO specifically are smart enough to know this is out of sync with what I did. I'm not going to touch it until somebody comes in and fixes it. And that's the number one failures we see on things is, something was changed underneath it. it's going to wait and not let you do anything until it's been brought into sync, and then it can redeploy. So we can actually go into the subscription and we can do what's called modify workflows. So here we have basically like update the admin state on a link member. So like if there was a fiber cut in the middle of the night, you know, I want to update the admin state. I believe, I haven't used this in a while. I believe this basically pulls that state from our source of truth, right? So basically the workflow would be an engineer goes, says this down needs to be down, make it so, redeploy that. And the same thing for like, you know, IGP metrics and things like that. You know, that's kind of a lot of that operational stuff happens from these modify actions on top of the subscription. That's the goal. Of course, the CLI is still there. If there's something really broken or really busted, like it is still there. We haven't turned it off, but you know, the idea is to put as much in here.
And what about the monitoring side of the house? So we've now provisioned a new service. We want to make sure that it's monitored, that the NOC knows about it, that we are going to get alarms. Is there any connection between the orchestrator and the monitoring handoff?
That's a great question. Yeah. So because the orchestrator talks back to ESDB, ESDB now has an accurate record of how services have been provisioned. And then we have monitoring tools that are separate from the orchestrator, because the orchestrator is not a full-blown NMS. And that's like definitely something that it's not designed to do. It's just a component in a functioning network. So we have other network monitoring systems outside of this that are pulling from the same source of truth. And that's the real beauty in my mind of having a accurate, up-to-date source of truth, is that you can have various systems pulling from that one place, and you don't have to have one system necessarily to rule absolutely everything. Like the orchestrator doesn't have to go out and say, monitoring system, look at this thing now, we configured it. Like it's updated in the source of truth. It's segmented off. We have nice little contractual API boundaries where other systems can pull from things. I've been kind of thinking too of it a lot as like documentation driven deployment of things instead of intent-based networking. Cause like in the older days of networking that we did at ESnet, right? You would just document what you did in ESDB, then you'd go and do it. And then, of course, something would change along the way. And so because of that, your documentation, the second you wrote it down, is always, always, always out of date, right? You can never really be sure that it's up to date. I really like the idea of having your documentation sources drive all of your deployments, because when you have that done, your documentation is the actual source of truth as to where things are and what they are configured as. And like, I think that that's a very, very important thing for being able to have accurate monitoring and just accurate inventory of services and all that stuff. Because if you're relying on a human to go back and update, oh yeah, I configured the service after the fact, it's always going to be out of date and not quite accurate.
Yeah, and I want to amplify a distinction there that I think you're glossing over a little bit, and that's the source of truth is the source of truth for the intent. And what we're trying to monitor for is when the intent differs from the reality of what's on the ground. And I think I hear a lot of times, because we talk about source of truth, people equate truth with reality on the ground, and that is not the case.
Oh, 100% agreed. And so the orchestrator itself, from an actual implementation standpoint of the SurfNet orchestrator, it has some layers of validation that it does to make sure that configuration intent is still configured the way it is. So like you can run nightly validations that check to see that somebody hasn't changed the configuration out from underneath you. And you can even do enforcement actions like, no, bad engineer, go back to jail, don't cross go, don't collect $100, like we overwrote your config, that kind of stuff, right? But that's not operational monitoring. That's just making sure that configuration consistency is the thing. And so that's where you have your network management systems and your alerting systems and all of that sits outside of this, at least in our deployment. But it's looking at the same source of truth, which has to be accurate so that you know what should or should not be up. And like, you know, a lot of times you would have issues where a port would go down, you know, the network operating center kind of comes and calls and is like, hey, on call, like, why is this thing down? Can you look at it? It's like, oh yeah, I was working on that, right? If you change that deployment mechanism to update the source of truth as you're doing those deployments, you can really cut out a lot of unnecessary wasted cycles between people.